All right, guys. Hey, one of your peers asked about a question that was on the quiz. It's something very similar to this, where after you subtract the number of periods, you got f of zero, but the graph doesn't exist at zero. All right, on the quiz or on the graph. And so, how do you figure out what's going on with at x equals zero when the graph doesn't exist there? All right, so let's look at that. Let's look at this one here. In this one, let's find our period. And so if we take these 2 points, and this one's at 5, this one's at 1, so my period is 4. Good. Okay, so let's see now what's going on with this graph at x equals 12. But 12 is not on, it's not given right here. It's somewhere out there. So I didn't know, okay, even though 12 is on the x-axis, this is a period graph. So one of these points right here, right, it's going to show up at x equals 12. But how do we know which one this was? Okay, and you can just subtract the period, right? So f of 12, we can write it as and the number of periods is, the period is 4. And so we're going to have 3 periods of 4. Good. And when we do our little math, that gives me f of 0. But wait a second now. The graph is not shown at x equals 0. Okay, what they want to do is, remember, this is a periodic graph. So the graph also, it goes into the past. It wants to say into the past. All right. And so you got to figure out now at x equals 0, where's the graph, right? At x equals 0. So you can try and sketch a graph backwards. And some graphs are easy to do, and some graphs are like tricky to do backwards. But what you can do is this: if you recognize that these 2 points, this points every 4 units in itself, right? Every 4 units. And so we can think of this as, let's say this is a starting point, that's the end point of the period. And so this point occurs at 1, right? But it also occurs at 5 again. So watch this now. If I say this is 1, right? If I call this 1 right here on the x-axis, because the point is repeating itself over and over again. So if I say this is 1, and if I go backwards, then this is 0, this is -1. If I go forward, right, this is 2, 3. And you can see that this point also occurs at 2 right here. See the trick right there? So so if I say this is 1, then this point is 0. If I go up, right, the y value at 0 is 3. So at 0, even though it's not showing right here on the graph, at 0, the y value, the output is 3. So f of 0, so f of 12, right? F of 12 is the same as f of 0, which is equals to 3. Let's do another one. Let's see. Let's try this one here. All right, here's another. All right, guys. Okay, here's another example. I kind of doctor this graph a little bit to kind of illustrate the point. And so, what is f of 30? Okay, what is f of 30? Well, let's see. If I pick these 2 points on the graph right here, right? These 2 points, I can see this is at 6, this is at 1, and so the period is 5. So the period is 5. And so this graph right here, so this period graph is going to repeat itself again out at x equals 30. We just don't know what part of that graph is going to show up there at x equals 30. But we can find them. All right, so here we go. So I can write f of 30 as, what can I write this at? I can write f of 30, right, as f of 30 minus the period is 5. And so I can write this as 6 periods of 5 minus 6 periods of 5. This is over 5, right? We get a picture, all right? And that is just going to give me f of 0. So f of 30 is the same at the point at x equals 30, same as the point at x equals 0. But wait a second. The graph doesn't exist at x equals 0, right? So, I mean, one option now is to extend the graph, right, backwards to see what the graph is at x equals 0. Or if you recognize this, right, that the graph, this point right here in the graph, repeats itself again at x equals 6. And also at x equals 11. And so if I call this point right here in the graph, this occurs at 1. If I say this is 1 now, this point in the graph, if I say this occurs at 1 unit, right? And if I go backwards now, then this is 0. If I go forward, this is 2, this is 3. And if you notice now, 3, right, this point right here at 3 is the same as this point right here. So 0 now, if I go backwards now, 0, right, the y value at 0 is, the y value at 0 is just 7. Right, it's 7. So 0 at f of 0, right? So we can say now f of 0, so f of 30 is the same as, oops, right, f of 30 is the same as f of 0, which is just 7. And in this case now, right, that 7, we say that's a relative max. Relative max. Now, in periodic function, right, there's no absolute max or absolute min. Okay, so let's clarify that now. All right, again, because let's use the famous one, the sine graph, right? It goes up and down, up and down. And so you're going to have the same y value over the highest, the maximum point over and over again. And so there's no absolute max. All you have is relative min, and relative max. Same thing with the lowest point. You don't have an absolute min, you have relative mins. Okay? And so hopefully that will kind of clarify how that partial, hopefully you'll see what the answer is on a partial question on the quiz. All right, that was a long video. I didn't kind of,